Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at back-to-back stem and leaf plots. So the point of these is to display data from two groups. So in our example, we're going to look at height of boys and girls. Boys is one group, girls is one group. We're going to display them so it's easier to compare them. So you're probably familiar with a normal stem and leaf plot. For a back-to-back stem and leaf plot, you have two leaves for each group and they're on either sides of the stem. So the stem is usually, but not always, the number of tens. So here for our heights, they go from the 160s to the 180s. So we have three groups here, all the 160s, 170s, 180s. So let's start with boys. So the first score we have to put in is 167. So we just put a 7 here. That score means 167. I know it's 167 because it's in the 16 stem. Similarly for 168 and 168. Now when you're doing a back-to-back stem and leaf plot, the scores need to be in order, so the lowest scores closest to the stem. So let's look at the 170s. So we have 174, 176 twice, so I'll write it twice. Then we have 178. As for the 180s, we have 180, 181, 183, 184, and 188. And we do similarly for the girls' scores. So looking at the stem and leaf plots, it looks as though the boys in this class are generally taller. But in order for us to really determine that, we calculate the mean and median of each group and compare those. So recall, to find the mean of a set of data, you just add up all the scores, divide by how many there are. So all the heights of the boys add to 2, 1, 2, 3. I divide by 12 because there are 12 of them, and I get about 176.9. As for the girls, if I add them all up, I get about 1886. Divide by 11 because that's how many scores there are, and you can use your calculator, of course. It's about 171.4. Now let's calculate the median of both of these. So if you need to calculate the median of a set of scores from a stem and leaf plot, a good trick is to cross out the highest, then the lowest, then the second highest, second lowest, and so on until you're in the middle. What do I mean by that? Well, the highest score here is 188, so I cross that out, then I cross out the lowest. Then I cross out second lowest, second highest, and keep going, crossing them out in this order, because what I'll end up with is the middle. So here, there are two middle scores because there is an even number of boys. 178 and 176 are the two middle scores, so the median is just the average of those. It's just halfway between 178 and 176, which gives us 177. And we can do the same for the girls. So you cross out the highest and the lowest, and then the second highest, second lowest, and so on. Keep going down like this and you will end up in the middle. So for girls, there are only 11 scores. So when there's an odd number of scores, then there's only one middle score. So here the median is not 3, it's 173. So from the back-to-back stem and leaf plots, we can also determine skewness. So here it looks like the boys are positively skewed. There are more scores closer to the maximum. It looks like the girls might be positively skewed. However, if you look at the mean and the median, they're pretty close for boys, and they're also pretty close for girls. So for this, you could probably argue that the boys are either negatively skewed or symmetrical, and for girls, you could argue positively skewed or symmetrical. It's not always clear-cut where the data is skewed. All right, the last thing I need to show you is converting this stem and leaf plot into a histogram. So to draw a histogram, always start like this. We have two axes. Scores are along the x-axis and frequency, or F, on the y-axis. So remember, frequency is how many times the scores occurred. So if we look at boys, we want to convert into a histogram. We really don't want to go, okay, 160, 161, 162, 163, all the way up to 188. That would take us a long time, and the data display wouldn't be useful either because very few of these scores are repeated. Instead, what we can do is draw a grouped histogram. We're going to group the data. We're going to group it exactly the same way we did in the stem and leaf plot. In the stem and leaf plot, we grouped it in tens, all the 160s together, 170s together, 180s together. We're going to do the same here. So what we're going to do is draw bars for each of them. So for the 160s, there were 3 scores in the 160s. So all we do is draw a bar. So notice this bar represents scores that start at 160, they end at 170. 170 would be included in the next bar. So this bar here represents this line here. It's all the scores from 170 to 179 inclusive. And there were 4 of them. So I draw the bar up here. I drew it up here, so it's in line with frequency 4 because there were 4 occurrences of a boy's height in the 170s. And then I would do the same for the 180s. So on. Now there were no scores above 180, so I stopped there. And now we'll do the same for the girls' heights. So for girls, there were 5 from 160 to 169. So we draw a bar from 160 up here, so it has frequency 5. Then there were 5 scores in the 170s, so we draw another bar there. And there was 1 score in the 180s. Again, there were none in the 190s, so we leave it there and we're done. So these histograms just give us another way to visualize the data and compare it. From the histogram, it looks like the boys' heights are negatively skewed, scores clustered around the maximum. From girls' heights, they could be symmetrical or positively skewed. Either one's fine. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.